How can we construct a 4D cube in 3D? In my previous video, I asked, if the sides of a regular 3D cube are 2D squares, then what will be the sides of a 4D hypercube? To answer this question, we just need to follow the dimensional analogy. What does that mean? Well, a one-dimensional line is bounded by two zero-dimensional points, a two-dimensional square by four one-dimensional line segments, and a three-dimensional cube by six two-dimensional squares. Therefore, the boundary of a tesseract, a 4D cube, is defined by 8 three-dimensional cubes. And because the boundaries are not 2D shapes, but 3D objects, that's why we don't call them sides anymore, but we call them cells. Now, if we imagine that one of the total 8 cells is transparent, just like before on the 3D cube, where one of the total 6 sides was transparent, and we look into the hypercube, we will see something like this. So what is this picture exactly? Well, this is a 3D perspective projection of a 4D hypercube rendered on our flat 2D screen. And very similarly, like before, one cell out of 8, the cotta cell, is not visible. It's outside this image. If it was visible, it would have covered these 7 cells that you can see on the screen now. Isn't it fascinating? That's all for now. Something's not clear? Write in the comments. And don't forget to follow or subscribe. You can now more or less imagine